prove the triangle proportionality theorem. And that says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So essentially, if you have a line of a triangle right here, so we have a triangle here, and line DE is parallel to line AC, and what it says is it will divide the sides, side BD, the proportion that it divides these two sides will be the same proportion that it divides these two sides into. And that's what we are looking at here. So it says, to prove this, it says given triangle ABC with DE parallel to AC, and it says prove that AD over DB is equal to CE over EB. So when we look at this here, I have DE is parallel to AC. We know that this is part of the given there. And then I have that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And those are corresponding angle postulates, because if I look at it here, I have parallel lines cut by a transversal, and corresponding angles are congruent. So angle 1 and angle 2 are congruent because corresponding angles are congruent. And the same way for angle 3 and angle 4. There's my parallel lines and my transversal. Corresponding angles are congruent. So by that, I know that those two triangles, or those three angles, are congruent. And from that, I can say that angle or triangle ABC, the big triangle, is similar to triangle DBE. And you have to think back about how we can prove triangles are similar. And I just proved that two angles are similar or are congruent. So this is the angle-angle similarity postulate, which says if two triangles or two angles of one triangle is congruent to two angles of another triangle, then the triangles are similar. So now we go ahead and we can say, okay, if I have AD plus DB, if I add AD and DB together right here, that is equal to AB. And they also say if I take EC and add it to EB together, that is equal to BC. And what am I doing there? This is one of the theorems or postulates that I told you had to remember because we would use it a lot. And actually, I'm just adding segments here. So this is the angle addition postulate. I don't know why I said angle addition. This is the segment. It's the segment addition postulate, okay? And so then I can put this up here, and now I have that AB over BD is equal to BC over BE. And we know that because since I have corresponding triangles, I know that AB over BD, okay? So AB, this entire length, over BD is the same as this entire length, AC over BE. They are similar triangles, so they have similar sides. So corresponding sides in similar triangles are proportional. I know that. So corresponding sides in similar triangles are proportional. Okay, I can spell proportional right. Okay, now I know that on the top here, I have AB and BC, and I already said what AB is. AB is equal to A plus D. And so what I can do in the next step is I actually substitute that in. And that's what I've done here is I've substituted what AB is and I've substituted what BC is. So this is just substitution. substitution property of equality. Okay. And then the next thing that I did is all I did is separate out the fractions. I said dB. And if you notice on the bottom here, I just flipped the bottom here because segment DB is the same as segment BD. So on the one hand, I left it BD. On the other hand, I just switched the two around. And it's the same thing. So it's just separating the fractions out. And then that brings me to, I have dB over dB and BE over BE. And that's just separate substitution, because something over itself is always equal to 1. I suppose you can say division property, because dB divided by dB would be equal to 1. Either way you want to look at that. And so that puts in a 1 here. And then when I get done, I just have this right here, and I have used the subtraction property of equality to get rid of that. So this is subtraction property of equality. And now I have that AD over DB. So if I look, I have AD over DB. So AD over DB is the same proportion as EC over EB.